Tejaswini, she's in New York right now, which is obviously the epicenter of the world of COVID. So she's currently working for IBM TJ Watson as a research scientist. And let's chat with her and find out how she's using computational thinking in her work. So hi Teju, thanks for joining us. So we're talking about computational thinking, so our students, can you explain our students how you're using computational thinking? And when I was chatting with you, you're telling us that you will give a lot of instructions to the computer, right? So you have to tell the computer on, hey computer, you do this for me. Then the computer will do that for you, right? So you give some set of instructions for the computer, because as we know, computers are dumb unless you tell them exactly what they're supposed to do, right? So you have to prepare the instructions. So what we are calling computational thinking is, it's the art of preparing your instructions to the computer, so computer can understand your instructions in the computer language. Then it'll give you the required output, right?
Right. Yeah.
So can you talk to us about how you use computational thinking techniques like abstraction, pattern recognition, and so forth, and how you all solve world problems?
Yeah, sure. So what we currently do is we are trying to see if given a data set for a particular problem, can we automate the task of building a machine learning model? So
what's machine learning? Can you quickly elaborate that?
Yeah, sure. So a machine learning model, to put it very simply, is mining for some rules on a given data, and when it sees new data, it will apply the rules that were extracted and try to solve the problem.
So computer automatically tries to see what the patterns are in the model and tries to solve the problem.
Right.
That's machine learning, simply put.
Yeah.
Okay.
So what we are trying to do is, there is the job of a data scientist is to actually look at the data and then try to build this machine learning models to solve the problem. So what we want to do is we want to see if we can automate a lot of the tasks that are done by the data scientists in order to solve the given problem. And the problem might vary. Shall I give some examples of what kind of problems we'll look at?
Please go ahead.
Yeah. So all of you might have come across machine learning models in day-to-day life. For example, you all have email accounts. And when you get an email, the email is classified into spam or not spam. So what is happening in the background is the email service provider actually looks at a lot of the past emails that you're getting, and then it will train a model saying if these kinds of emails which have, say, slightly weird email IDs, or if they have random text rather than well-meaning sentences, they're mostly junk. So when you train the model with these kinds of emails, it will try to extract some patterns, and when you get a new email, it will apply the same patterns.
Very nice. So this would be a classic example of pattern recognition that you're using in solving a problem there.
Right. Yeah.
Correct. Okay. Great.
So yeah. So first, I think the grand goal is to automate the tasks that are required to build this model. But first, we'll have to use decomposition to identify what are the tasks that can be automated. Because we know the end goal and we have a data, then we'll have to figure out how to get from the data to the model. So what we identified is the data cannot be fed directly to the model. We'll have to extract certain patterns to tell the computer that you'll have to look for these kinds of patterns in the given data. And then there are several off-the-shelf models, and then we'll have to choose one of those models to build the machine learning algorithm. So let me give you another example. So say, for example, an airline company wants to predict the number of flights that it wants to run between New York and San Francisco. So the data that it has might be just the date, the number of flights on at a particular time, and the number of passengers within these flights. So then we'll have to use certain kinds of pattern recognition, wherein, so say we know the date, so then we can identify if it is a weekday or a weekend, or which month it is. Maybe a lot of people might fly in the summer or sometimes in the winter to get away from the winter. So we'll have to identify the month, the date, and the time. Weather also plays a key role, because a lot of flights get cancelled due to bad weather. So we also want to provide the computer with the weather information as well.
So you're identifying what all the parameters that can affect your patterns.
Yeah.
In identifying patterns, so what all the parameters like weather and other other seasonal elements that you take into consideration, and establish a pattern.
Yeah.
So okay.
And we can also use abstraction, because now we know that these kinds of features or patterns are important to determine how frequent the flights would need to be. We can actually use the same features if, say, Uber wants to predict how many taxis should be deployed on a given day at a given time. Then we can say that if the weather is really bad, then people tend to take a lot more taxis. And people tend to take taxis on the weekends or at nights because they want to go out for dinner or something.
Great. So what you're saying is the solution that you have, which is applicable for flights, the same logic you're trying to apply for taxis, for the Uber taxis.
Right.
So that's obviously a classic example of abstraction. You're taking that logic and applying the same logic here for a different scenario, and solving a similar problem.
And we can also keep extending this further. Say, for example, you want to predict the number of customers that a given store would have. So maybe a lot more people would shop on the weekends, or say in the evenings if it is a weekday, or a lot more people would shop during the holidays because they'll have people over. So yeah, we can apply abstraction and try to use the same pattern that we recognized across several problems.
I see. That's fantastic. So given that the real world scenario, so what's your opinion of kids learning computational thinking and better in learning better English, or in learning better math? So what do you say about using these kind of techniques in learning better math, for example, or better science? So do you think you can apply some of these in learning these subjects better?
Yeah, definitely. For example, take the example of theorem proving. So then you know that the goal is to prove the theorem, but then you'll have to decompose. You'll have to decompose to identify what are the required steps to actually prove the theorem. And then maybe if you prove this particular theorem, can I apply some steps within this proof for a different proof? So that is, so then they can definitely apply computational thinking.
So would you say using these techniques can be applicable? I need to take a break. Hold on one second.
Yeah.
So would you say using these techniques, learning these techniques would help in their profession after they graduate out of their school, when they get into the real world, right? So what we're saying is computational thinking is not about coding, right? It's about solving a problem. It's about thinking process. So do you think this type of thinking process would help them prepare for their job, to do a better job, basically, in their profession?
Yes, definitely. I think identifying problems and see if there are certain patterns is very useful in a lot of places. So say, for example, I might be actually working in a factory, and I know that say a machine breaks down. Then it is very important for me to understand how to actually brainstorm and how to actually identify what might be the problems behind this. And then say I would have seen a similar problem, say few months back, then I should recall that and apply this, maybe apply that logic over here to solve a problem.
Okay, that's great. So that's what we want to know. So that's the whole idea of this class, right? So we want them to learn these
Right.
techniques, not so much from the coder's point of view, but learn these techniques so you can actually write a better code or prepare yourself in a way so you can learn better, right? So you have English, you have other subjects that you can actually learn better. So I thought this computational thinking is basically it's a tool for them to learn to enhance their learning rather is what
Yeah,
they
definitely. I think even when they're learning the subjects, they can apply computational thinking. Like, for example, say I'm always, say, not reading the question properly. That
Mhm.
might be the underlying problem. So if I use computational thinking, I can actually identify what the underlying problem is and then address it to help improve my score or in general, improve my understanding.
Okay, great. Yeah, thanks a lot, Teju, for your insights, and I appreciate it. And be safe, and
Yeah,
we'll chat with you later then. Thank you.
yeah, sure. Thanks, Pramod. Nice
Yeah.
talking to you.